In this lesson, we're going to look into how we can solve a linear equation, how we could isolate specific variables within a formula, and how we could also solve for linear inequalities. Now let's keep in mind that the purpose for solving a one variable equation is to determine the particular value of the variable or possible values of the variable that will make the equation true. So let's take a look at an equation like this. We know that this is a linear equation because we see that the highest power on x is 1. So in looking at the steps to solve a linear equation, I'd say that the most important and easiest step to do first is to eliminate fractions and decimals. So since we see a couple of fractions here, the first step is to multiply both sides by the common denominator. Now we could see that on the left the common denominator is, the denominator is 3, and on the right side the denominator is 2. So the common denominator would be 6, and therefore we can multiply both sides by 6. Now notice that on the left, when we multiply by 6, we simply get 6 times 1/3, which is 2. While on the right side, notice that 6 times 3/2 is going to give us 9. But we need to also remember that we multiply 6 times 2, which in this case is going to give us -12. That brings us to the second step, which is to eliminate parentheses. This is where we're going to apply the distributive property. So multiply the left side by 2, which gives us 12x plus 30. And we can multiply the right side, the x plus 2, times 9, which gives us 9x plus 18. And we drop down the -12. The next step is to simplify both sides of the equation. So 12x plus 30 on the left side, there's nothing to simplify. But on the right side, we could see that 18 minus 12 is 6, so we could combine the like terms. Now at this step, we're simply going to be shifting variable terms over to one side and the constant terms over to the other. So notice that subtracting 9x from both sides is going to give us 3x on the left, and subtracting 30 from both sides is going to give me -24 on the right. So we could see that the x is canceled on the right side, and the constants canceled on the left side. And at this point, we simply divide by 3, and we get our final result of x equals -8. Now notice that there's a couple of situations that are very special when it comes to solving linear equations, and it's possible for one of these two situations to occur. One situation is that all variables cancel out, and what we're left with is a false statement, something like 0 equals 3. If that ever happens, that means that we have reached something referred to as a contradiction, and therefore there's no possible value for the variable that is true. A second situation that could happen is if all the variables cancel, but we instead get a true statement, something like 0 equals 0. Now we'd know that there would be infinite solutions, because that would imply that any value that I plug in for x is going to give me a true statement. And therefore my solution would be all real numbers. So let's take a look at this example here. Here we recognize some decimals, and although we could go ahead and get rid of the parentheses in this first step, I think the easier method is to multiply everything by 10, which will immediately cancel out the variable, or cancel out the decimal. So notice that 10 times -6.2 is -62, but we also have to multiply the 10 times the -4 on the left side of the equation, which gives us -40. On the right side, 10 times 4.2 is 42, so we get 42x. And we went ahead and said that negative gives me positive, so 10 times 2x is 20x. Now we can distribute the -62. Well, on the left side, that gives us 62x plus 62, and we're still left with -40. But on the right side of the equation, notice that we have a couple of like terms. 42x plus 20x is 62x. And now if we simplify the left side by combining the like terms, we're left with 62x plus 22. And on the right side, we're left with 62x. Now remember that at this point we're trying to subtract the variables onto one side. So if we move the 62x from the left side onto the right side, notice that it cancels from both sides. And we're left with 22 equals 0. This is when we can recognize that there's no solution to this equation. The reason is 22 does not equal 0. That's a false statement. And secondly, whatever we plug in for x would cause me to get a false statement. And we can actually see that that would have been true back at this step here. Notice that on the left side, we're saying that multiplying the answer times 62 and adding 22 more is the same as multiplying the answer by 62, which doesn't make any sense because the left side will always be 22 more than the left, or than the right side. And therefore, anytime the variables cancel and we get a false statement, the answer is no solution. Now, sometimes we get equations that have multiple variables in the same equation. And these are often referred to as formulas because each variable will stand for a particular quantity. These are found in all kinds of real-world applications. And so let's take a look at this distance equals rate times time, or d equals rt. A lot of times that equation is perfectly fine the way it is. If we have rate and time, r and t, we can solve for distance by just saying d equals r times t. But we could also manipulate that first equation here in order to solve for t instead. So notice by dividing both sides by r, we would get d over r is equal to t. And that would be beneficial for us if we wanted to know the time. So this is what we're trying to do oftentimes when we're solving, I'm going to say quote unquote, solving a formula, because notice that we have multiple variables. So let's take a look at this formula here where, in this case, if we knew the values of a, p, and t, we could find the value of r. But what if we wanted to manipulate this equation so that we said p equals, and we found the value of p? Well, the way that we solve this is the same way that we ended up solving regular linear equations. The first step would be to eliminate fractions. So since I see that I'm dividing by pt, why don't we multiply both sides by pt? And notice that that's going to cancel on the right-hand side. Now, at this point, we can see that there's p's on both sides of the equation. But if we're going to solve for p, we need the p terms to be on the same side. So why don't we add p onto the left? Now this equation would be perfectly acceptable. This is, as you recognize, this equation here is exactly the same as the original equation that was given, except it looks different. We manipulated it a little. And this equation would be perfectly acceptable if we were interested in finding a. But in this case, we're trying to find p. So why don't we factor out p from the left side? So by pulling out a p from the left side in both terms, we're left with rt plus 1. Now we still haven't solved for p, but if we were to now divide everything by what's being multiplied by p, that's in this case going to cancel out that entire quantity in parentheses. And therefore on the right side, we find out that p is equal to a divided by rt plus 1. Both this equation and the original equation that said r equals are exactly the same. But notice that the bottom one is more beneficial if we're trying to find the value of p. So this is what we refer to as a formula, and we can solve them the same way as solving linear equations.